completing the square can also be really helpful for us if we are trying to change from standard form of a quadratic function to vertex form of a quadratic function. This problem, I want to change my quadratic function from standard form to vertex form. Right now it's in standard form. It's ax squared plus bx plus c. Remember, everything's listed out in individual terms, no parentheses. I want to change to vertex form, where I have y equals a. I'll write that over here too, just kind of as a reminder. Y equals a times x minus h squared plus k, where I have that set of parentheses and I can see my vertex easily. We did one strategy for this process in the first half of chapter 4, and that was where we took negative b over 2a and plugged that x value in. We found our vertex straight in standard form. And some of you guys did that just fine, but some of you also found that it's really easy to make mistakes. So completing the square gives us another strategy. All right, so I'm going to rewrite right below here what my equation is. And after I get to vertex form, I'm going to name the vertex, the axis of symmetry, and the y-intercept. So just like before when I was solving quadratic equations by completing the square, I want to figure out what number would have to go here if I had a perfect square trinomial. This y doesn't matter right now. Whatever number's under my thumb doesn't matter. It's really this x squared minus 10x. Okay, if I have this minus 10x, b is negative 10, divided by 2 is negative 5, squared is 25. I need this number right here to be 25. Needs to be 25. And right now I have 4. So to get from 4 to 25, I'm going to add 21 to both sides, giving me y plus 21 equals x squared minus 10x plus 25. And it's really important that this y stays here because this is a quadratic function. This would give me the graph of a parabola. All right, let's keep going with this. And I don't really like this y plus 21 over here right now, but we'll deal with that in a little bit. X squared minus 10x plus 25 is x minus 5 squared. And as soon as we write this as a binomial squared, you might be thinking, hey, that's really close to vertex form. All I have to do is get y by itself. Subtract 21 from both sides. And there we go. There's vertex form. Y equals x minus 5 squared minus 21. And to answer the last couple questions here, what's our vertex? Axis of symmetry. And y-intercept. Well, the vertex is really easy for us to figure out now. I'm in vertex form. H and k give me my vertex, which would be 5, negative 21. And again, you could get that same result by doing negative b over 2a and plugging your value in. This kind of avoids some of the room for error there. Okay, my axis of symmetry is x equals the x coordinate of my vertex. Don't forget that x equals because the axis of symmetry is a line. And then y-intercept. Now don't be fooled here because the y-intercept does not come from vertex form. Remember, your y-intercept comes from standard form right here. So my y-intercept is 4. All right. Now really, if you like negative b over 2a better than completing the square, I'm totally fine with you using that. This is just another tool, and one where you might find yourself making less errors than you did before.